We have today we have this system is a mechanical system, and its corresponding block diagram seen on the right hand side, and our objective is going to be to create a block diagram giving this bond graft model. I think that it is very important to always, when you do this kind of modeling and simulation using bond graphs, to get some sort of organized effort to do these things so that you can do them correctly with no mistakes. And one of the things that I'm suggesting here is sit back for about 2 minutes and look at the system. Recognize the elements that you have in there. Study the system. You say, this mass here is really this. The friction in here is represented by this, and this damper is this one. And in here we have the other mass, which would be represented on this other I element. This is over here, and the connection between this and this is done through this friction here, like that. Between these two is this one, and we have in between these two we have this damper and spring combination in here. So that's just a quick overview. And now what I would recommend is to follow, like I said, certain steps. I would say, why don't we just begin writing them? I think that would be nice. Why don't we just say steps in here, and then we'll see where we insert this. What does it want to insert? I think we need to tell it where, right? We need to tell where to insert, and so we're just gonna say, okay, these are the steps. I think I like to have it in a little bigger in here so that we can read really well. Maybe just for the title, one of the step number 1, what did I say? Recognize the elements. So 1 we say, and structure, I would say. So just take a quick look at how it is. 2, I would say layout the bond, or I would say this with the connection structure. You would say for effort and flows. In other words, I would say each connection has an effort and a flow. Let's do that. Okay, so we're gonna close this, and we'll go to here where we say draw. We have some nice drawing tools, and of course what we need basically right now are the lines. And what I would like to do is, as we go up here, we start with the top, so that we let's see, maybe with 2 would be good. No, 3, I think, so that they would be. Well, here's what I'm going to do. We are going to reduce this to make it a little more precise, the drawing. There we go. So we have this, we need to draw more lines. So this would be the 2 for the for this I element. Okay, maybe we'll go a little closer like that. And then we need like I said, to draw the lines for the R element, and this is gonna go like this. I wonder if we can do a duplicate of this. Yeah, we can. Good. So we can duplicate this. So this would be this R element. Just maybe I'll just put it like this. And then we need 2 for this R over here. I'm just laying out the connections, you know. So in here we go and put 1 in here. For that, and then we're just gonna go copy and paste, and we created this one. Now I am gonna create this one in here, and to do that I really need this too. So what I'm going to do, oh, it doesn't allow me to copy both of them. No, it won't. So I'm just gonna do a Control C, and then go over here, Control V, and then also another Control V. So that way I'll do those 2 for this, see? And then I need to do it for this and for this. So just lay out the connection, and then we're going to go over here and put it in here again like that. So we have this too. They are element over here, sort of like they are on the system. That's what I'm trying to say. So this have a different inclination, so I will draw again one line with the inclination like this, and then we're gonna go this way, yeah, and then we'll build it for the other element. So we have laid it out for this. So we have, well, I think we're missing something here. We don't have 2 for this in here, and so we might have to move things around. Well, actually what we could do is make this one, and then the R element is going to need 2 more. So why don't we do that? I'll just go like this, and then we'll have to do one for this right here, for the R element. And then, okay, I will lay out the structure with these lines like this, and then perhaps we'll speed it up by doing it hand drawing on that. And then this is like that. So that's this one. We have done that one. After this we need to move this ones, because that is supposed to be for this. Yeah. And then we'll move this ones a little bit over here. Yeah, that's that one. And then we'll move this ones here too. There we go. Now we need to do the structure for this side, and of course we need this same one. I think we're going to go over here and put it in there, and go down here and put it over here. So that's that one right here, that's this one, and I need two for this as well. So I could just do another one and bring it over here. Just correct the inclination a little bit. Okay, and then do it for this. And now we need this one. See, you see what I'm trying to do? I'm trying to not use that is going to be around here. See, so we go on that side, and then we put the other one, which would be sort of like that. That made this one. And then so I'm laying the whole structure as like a blueprint of this. So this is like this one. I am going to lay out over here. Okay, and then that's on the other side, this one. Just gonna put it like that. It's gonna be interesting how this turns out when I do the connections. And we are gonna have to set it up for this too. So we need this kind right here to be put over here, and we put those two signals for this in here. I think we need to separate it a little bit more like that, so that we give plenty of space for the connections. So that's this. Now we need this, we need that, we need this, and that. So I'm going to use this as my template, you may say, and then I put it here, and then the other one will also be here. So we have done this. Now we have to do the other one. It says in here we need another one. And the other one is going to be like that. You see what's happening? I did this one, did this one. Now I need to do this. And so for that I'm going to copy a vertical line which will go here. Okay. And then of course we need another one which will go over here. See? So that's this one. Now I need this and this, so I'll just need to copy this kind of line that I have in here, and then I will put it down here, and here are both of those. And then I need the other one for this one. This procedure of calculating, doing the structure sets us up in a nice way to do our bone graft model. So I just lay out the structure, and then you see that a lot of these things are based on the individual equations and the constitutive relations. So I think we have pretty much the skeleton of what we are going to do of our block diagram. You can start basically anywhere, because this is based on the equations of each element, and that's how we will put the signals here. I am going to deliberately use another color for the elements in here, and I'll just start with the I in here. You see, if I make a convention that the effort is going to be on the left if something is like that, and the flow is going to be on the right if something is like this, consistently I can do an E over here and also an F down here. And if it is like this would be E and this would be F. So okay, we go in here and for this I over here like this, you see that the effort is what is going into the I, so it's going to be like this. This is like E sub 10, right? But out of this comes F10. So F10 is the result of this effort going in and being integrated once, like I am going to use the notation and Simulink 1 over S, and then you multiply it by 1 over I, and out comes F. That's that one. The constitutive relationship of the R element right next to it, what does it say? It says that the flow goes in and the effort goes out. So flow goes in like this. This is F16. I didn't read this correctly. Guys, you should correct me. This is not 10, it's 15. This is F16. And out of that comes E16. Like this. So what this is saying is that this in here multiply by the R element comes out to be the signal like this. I think perhaps I should do a little better job about this, and I'm just gonna I'm going to erase this so that it would be much better. So in here, let's build it nicely here. There you go, like that. Then I am more satisfied with that. Like I said, we are building the constitutive equations of all of this. So this on this E9 is the output, and this is F sub 9. And how does this work? You just did the same thing right here. There's our element like this, and then if we go on the other side, just to go from top to bottom, this you have that E10 is the output in here. So you see how the structure helps a lot to keep it nice and neat. And in here it's obvious that what we have done is, well, we could also write it like this, or we could draw it horizontally. It doesn't really matter as long as you have it correctly. So we have done the constitutive relationships for those, and so we say lay out the connections. I'm sorry, I should have done step number 3, which would be I would say draw the constitutive relations of each element. Okay, and then after this I need to do this I, and I need to do the SE here. So let's see. So what number is that? 2, right? So the flow is the output. So in this case you have that f sub 2 is like this, that e sub 2 is like this. And how does this how does it happen? I think the first thing, well, let's see, how do we draw it here? We need to either draw it an incline, maybe we will draw it at an incline 1 over s, and so it gets integrated, gets multiplied by 1 over I, and then out comes f. See, that's that one. The one for the I think this is a source of effort, and the bond number is number 1, and in here, so E sub 1 is the one that comes this way, and F sub 1 comes this way. So in here basically we have the source in I'm just going to use this notation because to know that this is not a transformation of a signal F1 into E1, but rather is a source of E1. So this really is a signal that is 0, in fact. So in here we have a on bond number 7 and number 8. The R element has E sub 8 as the output. So it would be this one right here, E sub 8, and this would be F sub 8. So F sub 8 comes in and then gets multiplied by the R sub 8, and then this gets like that. And then if we go for the C element in here, this one right here, 7, you see that the effort is the output. So in here you have E sub 7 like that, and you have F sub 7 like this. And so what is that you have? F7 comes in and gets integrated once, like that's 1 over s, and then gets multiplied by 1 over c, and then out comes E7. I mean 1 over C7 is what I mean, right? So that is, so which ones we haven't done? The ones on the left, the I and the R element, we haven't done it. So that is bond number 3 and number, I can read it very well, 19. So 3 is on the I and in integral form. So this is the effort E sub 3 is the output, and the input is F sub 3 like this. The way we have this is, first this gets integrated, okay, like 1 over s. Wait a second, let's just draw it correctly, okay, so that we have enough space. I am just going to draw it as I have been doing it. Can we move a little? Yes, we can, just a little. So this is 1 over s, and then gets multiplied by 1 over I, and then out comes this. So that is this one right here. And now we are about to do the number 19, which is the R element, where the output is E19. So the output is E19 like this, and the input is F19. And in here you have the same situation. This would be the R element like this, R19. So what we have right now, let's make an evaluation of what we have. We have the skeleton of the bond graph model, of the block diagram. We have the constitutive relationships of each element. We have drawn those. And now I would go and do a step number 4, which would be I will say draw the summation points for E's and F's, and here we need to say consider the signs. Okay.